this foundation course for them. But for the mechanical, it is going to be a kind of a mystery. They wanted to unveil it. Okay, therefore, I am trying to give only the fundamentals related to electric vehicles and hybridization, how it is going to be, how it works in real life problems. Okay, so this is the background of my today's lecture. As everybody requested me in the previous lecture, I am starting my presentation with respect to the hybrid vehicle, what types of hybrid vehicles you are having, and then how this is being connected to your vehicle, and what are the behind of what is the technology behind of it, or what are the components it will go into that electric vehicle. We'll try to discuss today's class. Okay, let me share my PPTs to you. Then, if you in between, if you have any doubts, you can ask me at the end. Okay, make a note of it. Okay, I will be closing my session by maybe around 7:15. You can have interaction of 10 to 15 minutes for that. Okay, right. Can you able to see my screen? Hope
Yes, sir.
you are
Yes,
all able
sir.
to see my screen.
Yes, sir. It is visible.
Not clear, sir.
Yes. So I'll make a presentation mode. Yeah. So yesterday we started here about the different types of drives you are having, four-wheel drive, those things, and then here we stopped here. Okay. So now we will try to discuss today the classification of electric vehicles for EV drives. Okay. Here for the EV drives, you will be having AC machines or DC machines. Okay. In AC machines, you come across induction motor, and then permanent magnet synchronous motor and switch reluctance motor. In short, we can call as a PMSM, and we call it as a SRW. And this is an induction motor. We just simply call it as okay. And other types of drives are going to be DC motors, rather I can say, to be precise. And these are going to be two types of it. They are brushed DC motors, brushless DC motors. Okay. In the brushed DC motors, you have separately excited, series excited, shunt excited, compound excited, permanent magnet, brush DC motor, something like you are having it. Okay. Uh, Here, this DC motors normally used for high efficiency, high power density, and they are in a simple in control is concerned. Okay. And in this brushless motors, you will be having outrunner and runner. This how this looks like the shape, and again the construction how it looks like. So we'll try to discuss in subsequent slides. Okay, right. So now these are being used in the form of to propel this vehicle. Apart from this, there are many components which are required for an electric vehicle. We'll try to discuss with the next slide, which is coming soon. Okay. Now, if you see, the vehicle looks like this one. Either it is a four wheel or two wheel. Two wheel. This is front wheel drive. This is a rear wheel drive. Whatever the drive you are going to have it. Okay. So the hybrid vehicles can be classified into series hybrid vehicle, parallel hybrid vehicle, and series parallel hybrid vehicle. In based on that, now how it is connected to the vehicle, right? So here, if you see in series hybrid vehicle, the engine is used to produce a mechanical work, and this mechanical work is converted to generator, and this generator is right try to store that in an inverter. This is a form of inverter, right? And then this battery, if battery is there, let us take here inverter. Why do you use inverter? Is nothing but in order to convert DC to AC. The generator develops DC power, and to convert this DC into AC, you will be having inverter. And here also battery is also stores energy in the form of a DC. If you want to convert it to AC, it is going to inverter like this, and there is a motor, right? This is AC motor here, and it runs the vehicle. This is called a series motor. Means what? You do not have direct contact of the engine with the wheel. This is series motor. Okay. Are you following me? I mean, right. This is very, very important. Okay, now if you go to the parallel hybrid electric drive, it can use the engine power as well as battery power to run the vehicle. Okay, and then series parallel. This is a combination of, you can have it, right? This is a combination. It means what it is. Sometimes it behaves like a series. It behaves like a parallel hybrid vehicle. Okay, right? Now, so once you know this is principle how it is going to attach to your vehicle, then we'll try to talk about the different types of hybridization. Okay, so the electrification level, which is typically indicated by battery voltage, the electrification level is indicated by battery voltage, storage energy, and power, uh, determines the electric path capacity and limits the energy saving tools of every hybrid electric vehicle or electric vehicles are concerned. Okay, so small comparison I have made it here. Comparison among EVs based on varying level of electrification. So here I can say we can call it as hybrid vehicles can be one five six types we can call it as. Okay, so first one is nothing micro hybrid electric vehicle, mild hybrid electric vehicle, full hybrid electric vehicle, plug-in hybrid electric vehicle, extended range electric vehicle, and pure electric vehicle. Means what? It is only runs with a battery electric vehicle, BEV also sometimes people used to call. Okay, right? So here, when you classify this hybrid electric vehicles into six types, right? So here it based on that the requirements for the vehicle, it can be classified, right? So let us say your requirement is idle stop. So when you use the vehicle at park, right? It ideally stops and it tries to energize the vehicle, right? Means that regenerating mechanism is there here, right? When you stop the vehicle, still your vehicle is trying to run, so that energy which is generated by the vehicle is going to recharge the battery. That is something like regenerative mechanism is there. And mild hybrid vehicle also there is a regenerative mechanism is there. Full hybrid vehicle not at all not applicable for that. Okay, sometimes plug-in hybrid vehicle also not applicable. Okay. Now power resistance, you can see here the mild hybrid vehicle, it won't try to propel your vehicle, right? Power resistance is not there, right? No, yes, partially is there, yes, fully power resistance it can obtain it. Yes, fully you can obtain it. Here also you can obtain it. Here also obtain it. Now regenerative braking. This is one of the important, right? When you apply the brake, you don't have the setup to regenerate the battery, right? Here it is partially possible, it is partially possible, yes, it is also possible, it is also possible, right? Right, you need not necessary to charge the battery. Plug-in electric vehicle driving mode is not there in case of micro hybrid, not in a mild hybrid electric vehicle. Here you can have plug-in vehicle. Means what? When your vehicle is kept it idle or otherwise you park it in the garage, you can plug it and then you charge the vehicle is concerned. Okay, and charger, when we based on the different component, charger is not at all required, not at all required. Yes, plug-in hybrid vehicle you require it, and range extended electric vehicle you require it, and pure battery kind of thing you require a plug-in charger is required. Okay, voltage normally 12 to 48 volts. Your hybridization you can able to see get it, and 48 to 160 volts you can able to get it. From 300 plus you can get it, 300 plus you can get 300 plus you can get it. So based on this, it is going to know the thrust it can able to generate it. I mean to say here, okay, and effectiveness is going to maybe 2 to 4% something like you can have here. Okay, however, this this type of configuration we has taken as no the distance between mild to full hybrid vehicle up to here. It is depends on the percentage of hybridization you are following it, right? The distinction between mild hybrid electric vehicle and full hybrid vehicle is rather confusing. The evaluation criteria for mild and and strong hybrid full size vehicles are derived from mild and strong hybrid vehicles requiring recovery energy by regenerative braking during deceleration by federal test procedure will be at least 15 to 65% respectively. So based on this, you will have the different types of hybridization. Based on this different percentage of 15 to 65%, you can have the classification like micro, mild, full hybrid electric vehicle, something like you can have it. Okay. So Toyota Prius and Ford Escape are well recognized as a full hybrid vehicle. Means that it can have a voltage of 300 plus volts it can have it, and effectiveness around means that hybridization is going to be 20 to 35% you can have it. Okay, right? Examples of mild and hybrid electric include GM Chevrolet, the model name is Malibu with E assistant system, and Honda Insight with integrated motor assistant system. It is having it mild hybrid electric vehicles. Okay, so range extended vehicles are normally what we know is nothing. It is fully plug-in electric vehicle only, but it will have a gasoline power arrangement is also there. Means when your battery is exhausted and to charge it, it may require some time. During that time, it can be propelled with the help of a gasoline vehicle. Means what the gasoline vehicle is used for the extension of the drive range. That's why we call it this is called range extended electric vehicle is concerned. Hope all of you are following and my voice is clear.
Yes, sir. Audio is clear, sir.
Yeah. Okay. Any doubts are here from these two slides? Any participants from that? Okay. Now let us go to that pure electric vehicle powertrain architecture is concerned, right? So I am trying to concentrate on the pure electric vehicle architecture. See, if you see this configuration, I'm trying to show you here how it looks like. Okay. So as said already, the electrical people knows little bit, and the electronics, power electronics people know some of the things. But mechanical people, they are trying to learn this subject. Therefore, for them, it is one kind of kind of a mystery, or otherwise a kind of a enthusiasm they are having to learn this subject. The topic is concerned. Okay, so this is based on these two lines. I can say this is mechanical work. So electrical motor will propel the mechanical transmission, and this is going to propel these wheels. Okay, now this electric motor is going to receive electrical links. These are through electrical links. These are all electrical links. Okay, and this is controlling. This is controlling. So when you apply brake or when you apply accelerator, right, electronic control will tries to uh, uh, get that power converter activation, and then it rotates this electric motor, and it is going to uh, right, transmit this energy from here to here. Okay, now here this electronic controller is managed by this energy management system, and all the components you can able to see here. Okay, this is steering, right, power steering unit, and again you can see this is actually power supply for power steering, and energy source is there. Energy refueling unit is here, means that you can plug in here, and this is going to be the arrangement you are having it. Okay, this is temperature control unit, energy source subsystem. These are all the arrangement it is having. Okay, right? So this is a kind of a block diagram which we'll talk about now. Pure electric vehicle setup is looks like. Okay, various powertrain designs for pure electric vehicles can be characterized based on the locations and number of electric motors. Location, number of electric motors, and type of gearbox here, and number of gears among others it can be designed as. Okay, now in contrast to hybrid electric vehicles, electric vehicles include a more adaptable configuration, because here these are all you do not have any mechanical linkages here. Therefore it is more adaptable configuration you can have it, pure electric vehicles compared to mechanical or otherwise conventional electric engines are concerned, vehicles are concerned. Okay, in EVs, the primary mode of energy transmission occurs through the use of flexible electric wires as opposed to bolted and branches of stiff shafts. Therefore, implementation of distributed subsystems in electric vehicles is highly feasible. That just now I mentioned it here. Okay, and EVs provide many propulsion configurations, including independent four-wheel and in-wheel drives. Okay, so you can keep on this one motor in this, you can one meter, you can keep one motor here, you can one meter here. These are all can be integrated with this energy management system. You can run that vehicle. Okay, therefore it has a flexibility for the vehicles uh, powertrain is concerned. Okay, so the electronic controller, when I go to here, this electronic controller, this function of this electronic controller, what it does is nothing but the electronic controller utilizes control inputs from the brake and accelerator pedals to generate appropriate control signals for activating or deactivating the power converter. This activating or deactivating this power converter, it is done by this one. Okay. This power converter is responsible for regulating the flow of power between the electric motor and the energy source. This is going to be done by this one, electronic controller is concerned. Okay. Now, next. So, now ultimately, the phenomena of backward power flow occurs as a result of regenerative braking in electrical vehicles. Sometimes regenerative braking is nothing but, see, forward motion is going to be vehicle profiles. When brake is applied, it is going to be backward motion is happening. Okay. So due to that, okay, the energy management system unit is going to be very crucial, right? Engine management unit collaborates with the electronic controller to regulate the process of regenerative braking, and its subsequent energy recuperation is there, right? So it also collaborates with the energy refilling unit to monitor the energy source utility and control refilling also. So this is very, very important unit, energy management unit. It collaborates with electronic controller to regulate the process of regenerative braking and its subsequent energy recuperation also. It is done by energy management system. Okay. Now, the auxiliary power supply is responsible. Here, if you see auxiliary power supply is shown as, some kind of a element, right? So auxiliary subsystem, this one. Okay. So this auxiliary power system power supply is responsible for delivering electricity at various voltage levels to all auxiliary components like headlamps or otherwise AC, some of the things you can say, power window, those things with a particular focus on temperature control and power steering. In present days, EV configuration use, in present days, EV configuration use three-phase motors. I am trying to show you in this one, okay? This motor I mentioned, no? This may use three-phase motor. Three-phase motor. The power converter is a three-phase pulse width modulation inverter, mechanical transmission based on fixed gearing and differential, and lithium ion battery. Normally nowadays, the most advanced batteries at present in the market is going to be lithium ion battery. So lithium ion battery is typically selected as the energy source for it. Okay. Okay. Now finally, when this P propulsion is equals to, I'll read out. P stands for propulsion power, V stands for battery voltage, and I stands for battery efficiency. Eta stands for battery efficiency. I stands for battery current, and eta inverter efficiency, and eta nothing but motor efficiency, and this is final drive. This is going to be wheel drive, wheel efficiency. So now, if you want to find out, propulsion power of a vehicle is going to be the product of battery voltage and battery current into battery efficiency and inverter efficiency and motor efficiency and again final drive efficiency and wheel efficiency. These are all come into picture to find out the propulsion power of your vehicle. Okay, so this is about uh, the main part of the motor is concerned. Now I'll be going to the next part, uh, and for which I just wanted to show you a video how the electric motor will works. Okay, then I will come to this topic is concerned. This slide is going to, I'll discuss about it. Okay, Srinivas Reddy, uh, yes please.
Sir,
Can I play the audio video please?
yes, sir. Yes.
All of you able to see it and uh, grasp the concept of it. Okay. Just a second. Is it going to play? One second. It is taking time. I do not know.
Sir, otherwise,
No, no, I'll play it. Okay, 1 second. Another video is there. Are you able to see this one? Screen?
yes, the screen is visible, sir.
Pardon me?
The screen is visible, sir, but no video is being played.
Yeah, 1 second, then I'll show you. Are you able to see it now, video? Yes, please.
No, sir, still it is not loaded.
Yeah.
హలో రెడ్డి సార్
సార్ సార్ డిస్కనెక్ట్ అయినట్టుంది ఒకసారి కాంటాక్ట్ చేస్తాను
సార్
హలో శ్రీనివాస్ రెడ్డి చెప్పండి. చెప్పండి. అవునా? ఒక్క నిమిషం. ఇప్పుడు
But how does the electric motor work? You turn it on and somehow it starts rotating. Why is that? In this video, we'll cover the basics of electricity and magnets, and then put it all together to understand how the motor works. This video is sponsored by Brilliant. Let's start with something called a circuit. You have a battery, some wires, and a device that uses electricity such as a light bulb. Electricity flows through the circuit. But as soon as there is a break in the wire, the electricity stops flowing and the light bulb goes off. The path must be complete for the circuit to work. This is best done through the use of a switch. Electricity is flowing down the wire. This is called conventional flow. If we take the battery out and flip it, then the current will flow the other way. The light bulb will still work in either case, but there are some devices that will work differently depending on which way the current flows. Okay, so that's the basics of a circuit. Now let's come over here. This is a magnet. It has a north pole and a south pole, and it likes to attract other metal objects like these paper clips. If you bring another magnet towards it, opposite poles attract, and the same poles repel. Magnets don't have to be in this shape. For example, some magnets might be more flat like this. You can think of this magnet as always on, it's always working, you can't really turn it off. That's why it's sometimes called a permanent magnet. It's made up of many smaller magnetic domains that are lined up in the same direction. But later I'll show you a type of magnet where this is not always the case. Let's take one of our permanent magnets and drill a hole in the center and put it on something that will allow it to spin. Now bring another magnet towards it. Our spinning magnet will immediately line up until opposite poles are right next to each other. Now switch out the side magnet. The same poles repel and opposite poles attract. If we keep switching out these side magnets, then our spinning magnet will just keep spinning. This concept of the spinning magnet is really important. We'll come back to it in a moment. Here's a metal bulb which is not a magnet. It's made up of magnetic domains, but they are pointing in random directions. Now let's take a wire, wrap it around several times, and then create a circuit. The current through the wires forces the magnetic domains to line up. That means we've just made a magnet, or more specifically, an electromagnet. It can do the same things that a permanent magnet can. It can pick up pieces of metal, and it has a north and a south pole which will attract or repel other magnets. But the electromagnet is special in the sense that it can be turned on or off, just like the light bulb. You can't do that with a permanent magnet. Now watch what happens when we flip the battery. The electric current was flowing this way, but now it flows the other way. This will cause the poles on our magnet to switch places. North will become south, and south will become north. This is called reversing the polarity of an electromagnet. Instead of flipping the battery, an easier way to do this is to just switch the wires. You should be aware that the electromagnet will get very hot if it's on for a while. Just a caution in case this video inspires any science projects. Let's come back to our spinning magnet. This time we'll replace the spinning magnet with our electromagnet. As soon as we connect the wires, the magnet turns on and it lines up with the side magnet. Now, in reality, connecting these wires would prevent the bolt from spinning freely, but what's important here is the concept of the spinning electromagnet. Now let's switch the wires to reverse the poles on the electromagnet. The same poles repel and opposite poles attract. Now reverse the polarity again. Same poles repel and opposite poles attract. If we keep switching the polarity, our electromagnet will just keep spinning. To make this stronger, let's bring in another permanent magnet on the side. Notice how this side has the south pole towards the center, and this side has the north pole towards the center. The side magnets work together to spin the one in the middle. This right here shows the very basics of an electric motor, but we need to make a few improvements. The two side magnets can be replaced with stronger curved magnets. And instead of a bolt with wires, we're going to use a metal loop. This is called the armature. Connect our wires and we have a circuit again. This time you can think of the electromagnet as flat like this with the south pole pointing up. Now the armature will spin until opposite poles are lined up. We can keep it spinning by switching the wires just like we did before. But this is a lot of work to sit here and manually switch these wires. We need to add something to the armature called a commutator. It's a ring with gaps on the opposite sides. The commutator will spin along with the armature. Now we connect the circuit with two brushes on the side. These brushes will slide along as the commutator spins, and they are spring-loaded so that they always maintain contact. The current flows from the wire, through the brush, the commutator ring, the armature loop, and back through the other side. Now we have our electromagnet and the armature spins. As we come around this time, the brushes will switch contact to the other side of the commutator ring. Remember, there's two brushes, so this is happening on both sides. Before the switch, the current in the armature is flowing this way. After the brushes switch sides, current will flow the other way. This means the electromagnet switches polarity, which will cause the armature to keep spinning. This commutator ring does the same thing as switching the wires like we were doing before, but this time it does it all on its own. It will continue to spin as long as we're connected to a battery. Disconnect the battery, no more electromagnet, and the spinning stops. Now so far we've only used one loop on the armature. This will cause our motor to have an irregular speed, and in fact, we could get stuck in this position, with the brushes halfway between commutator segments. What we can do is split the commutator ring and then add another loop. So first, the brushes are in contact with these two commutator segments, which turns on this electromagnet, which causes it to start spinning. Once we get to here, the brushes switch contact to the next pair of commutator segments, which means this loop turns off and the next loop turns on. Now this electromagnet wants to spin. The brushes switch contact and the next loop turns on. This keeps happening as our motor spins. It's almost like the loops will take turns being an electromagnet. Some electric motors will add many loops to the armature. This ensures that there will be a continuous spinning motion on the motor. This spinning force on the armature is called a torque. Stronger torque means a faster spin. There are some things we can do to improve the torque of the motor. Electromagnets are stronger when there are more wires. This is true when we wrap more wires around the metal bolt, and it's also true when each of our armature loops are made of many wires. The motor will have stronger electromagnets, which means it will spin faster. If you look at some pictures of real electric motors, you can see lots of wires wrapped around. And yes, this is the same reason. More wires wrapped around means stronger electromagnets. Another way to make this stronger is to use more electricity. Let's learn a few more terms here. The part that doesn't move is called the stator. In this case, it's the two permanent magnets on the side. These fit inside the edges of the motor case. The armature in the middle is also called a rotor. Remember, this is the part that spins. The axle goes through the middle here and then sticks out the back of the motor. What I've shown you in this video is called a DC motor. If you have a device that moves and is powered by a battery, there's a good chance there's a DC motor in it.
Hello. Yeah, I'm audible. Now I'm audible, I believe.
Yes, sir, you are audible.
Yeah, yeah.
Yes, yes.
So now I'll go to another concept of it, right? This is not DC motor, which has got commutator as well as brushes, right? Now I'll go to other concept of it. Just have a look of it.
In this video, we will talk about a DC. In this video, we will talk about a reliability, low maintenance, less noise, speed control, and low cost. Specifically, we are going to see how a brushless DC motor works. We can assume already by its name that this type of electric motor has no brushes, as we have already seen in our previous video about the working principle of DC motors. The brushes are sliding devices which allow the electricity to flow into the copper coil of the engine. The brushless motors have no sliding elements on the collector, so this completely solves the problem of maintenance and replacement of brushes and other electrical
Is no voice or? Yeah? Srinivas Reddy garu?
Sir, audio is okay, sir. Okay, sir.
Video is not playing?
Video is also playing.
Okay, somebody's mentioned no clarities or something.
No, it is coming. I think
Yeah,
the
please,
network issue is on the side. Please continue.
contacts. JAIS, in its catalog, offers a wide range of brushless motors of the major manufacturers. Unlike the common DC motors that use brushes for their functioning, brushless motors do not produce sparking or friction noises within them. This is a very interesting feature of brushless motors, because it allows them to be suitable for use in environments where sparks are dangerous. For example, in environments where ignitable gases are present. This type of motor has a rotor with permanent magnets. It could not be otherwise, since there are no contacts on the rotor, as we already said. Its stator has electromagnets excited by windings and coils. This is an important difference compared to the traditional brushes DC motor, since the latter can have both stator and rotor composed of electromagnets to increase the magnetic fields and therefore have a higher mechanical power density by unit of weight of the motor. The torque of the brushless motor is due to the magnetic interaction imposed by the electromagnets on the permanent magnets. There is a precise sequence of excitation of the electromagnets which imposes to the permanent magnets an angular movement, which is always in the same direction, and it is as constant as possible under the same excitation. Obviously, the sequence is cyclical, and the rotor continues its rotation until it's powered, repeating the sequence from time to time. To be more specific, the sequence of excitation of the electromagnets inside the stator is such that the magnets of the rotor are attracted to the electromagnets without ever reaching them, as the excitation is always and only of those coils, not yet reached. When electricity flows into coil 1, the opposite poles of the rotor and stator are attracted to each other. When the rotor is getting close to the coil 1, the electricity flows in the coil 2. When the rotor is getting close to the coil 2, the electricity flows in the coil 3. Later, in the coil 1, the electricity will flow again, but with opposite polarity. This process is repeated continuously inside the engine, ensuring a constant rotation of the rotor. An example to better understand this principle is represented by the dog race, in which a hare is placed in front of the greyhounds at such a distance to be seen but never reached. In this metaphor, the dogs represent the rotor that follows the magnetic flux generated in exact sequence in the coils of the stator. In the case of more coils, always multiples of 2, it makes sense to use a sequence that uses them all, to increase the magnetic flux to which the permanent magnets are subjected and turning off only the opposite electromagnets. This simple foresight increases the torque, that is the power that the motor can supply, without substantially modifying its design criteria. The greater the number of coils, the smoother is the rotation of the rotor, which will thus have a constant torque. But how does our brushless motor know the precise movement in which to excite the correct sequence of electromagnets, which will allow continuity of the rotary motion. For this purpose, an electronic controller is typically used. This controller has a sensor to detect the exact position of the rotor magnets and thus decide which coil to energize by following the right excitation sequence. The modern brushless motor sensors use the Hall effect. In this animation, we can observe the configuration of a standard sensor. This is a simple two-pole device that can drive 2 or 4 or 8 or more electromagnets in the just seen sequence. This is instead the
Yeah. Oh, yeah. One second. Hello.
Sir,
One second, and I'll rejoin it. Oh, I do not know why different screens are showing. Okay, it is not going to the next slide.
uh, sir, try to stop the share
Sorry.
and then screen మొత్తం షేరింగ్ ఆపేసి ఒకసారి మళ్ళీ presentation ఒకటి షేర్ చేయండి సార్. That will check.
This one I'm trying to share this one, but I'm not able to see in that. Two PPTs are appearing. That's the problem. Okay, right now it's okay.
Yes, sir. Yes, sir.
Now it's okay, right? Okay. So ultimately, the principle I try to show you with the help of video. Okay. This looks like in our normal textbooks we try to follow. This is this arrangement you will be following in case of to explain that fundamentals of your uh, DC motor, how it works, right? So you can see this is how this is called as armature. You all of you know. This is two coils are there, okay, and this is nothing but this is the flux, okay, and this is the length of the armature, okay, and this is rotation dia, something like, okay. Now, so the principle I am trying to explain to you with the help of this diagram, okay. It functions this DC motor function on the principle of known as Lorentz force, which refers to the force that is exerted on a conductor, the force which is exerted on a conductor that is carrying a current when it is placed in a magnetic field. Okay, so that is equals to we can say F is equals to Q of E plus BV something we are defining it Lorentz force. Am I right? Those who are from electrical people they can clarify me. Okay, right now the working principle is something like this. when an electric current carrying wire is positioned within a magnetic field, a magnetic force that acts on the wire will be generated. The force acts in a direction is orthogonal to both the wire and the magnetic field. The magnetic force is proportional to the length of the wire L, the length of the wire L, the magnitude of the electric current, and the density of the magnetic field B, and this is given by F is equals to BIL. This is very well known. We study at our elementary school level. Okay, and this torque developed is equals to force into that radius we can consider. The torque that is created by the magnetic force is going to be T is equals to BIL cos alpha. Right, and the performance of DC motor can be characterized in a practical sense by the armature voltage. This armature voltage, what you are giving it just now in the video also you have seen it, and again electromotive force and the field flux what it is having. Okay, now this is the components of your electric motor. Already it is clearly explained by this video, so I do not want to go in detail about it. The components are going to be stator, rotor, commutator, brushes, bearing, and housing. Right, the commutator switches the direction of current flow to maintain continuous rotation, and the brushes always engages with the commutator. That also you know about it. Okay, now now very important principle is here, the Fleming's right hand rule. This is very important, everybody to know about it. Am I able? See, this is your right hand finger, right? Right hand finger. This right hand thumb rule is used for no. Fleming's right hand rule is used for a generator. Left hand is used for motor is concerned. DC motor is concerned. So if you see here, this is going to be the what is called a mass on your palm, right? If you hold like this, and this thumb will shows about the motion of this one. Okay, it is something like this is the flux. It is going to be the flux. Okay, this is going to be EMF. Okay, now keep into view how it is defined. I'll try to show you how it is defined. Yeah, keeping the first finger, second finger, and thumb at right angles to each other, similar to three axes like X, Y, Z. You can see X, Y, Z. Right. If the first finger points out in the direction of magnetic field, the thumb in the direction of motion of the conductor, then the second finger points the direction of the induced EMF. Okay, and this is the direction of induced EMF you can able to see. Okay, now the next concept is nothing but what is Fleming's right hand rule, to which it is used. What is Fleming's left hand rule, to which it is used. Okay, that I'll try to show you in the next slide. Yeah, the Fleming's left hand rule is used for motors to find the direction of force on a current carrying conductor in a magnetic field. Okay, and while the right hand rule is used for generators to find the direction of the induced current when a conductor moves in a magnetic field. Right, both the rules use thumb, forefinger, and middle finger, right, to represent the force, magnetic field, and current respectively. But the left hand is used to determine the effect of a current. Fleming's left hand rule is used to find the effect of a current, while right hand is used to determine the current produced by motion. Okay, so means that right hand is used in case of a generator, the current produced by motion, and left hand rule is when you give a current to that motor, the effect of a current you can able to see. This is the something like related to Fleming's left and right hand rule is concerned. Okay, for that again some explanation is shown to you how this is going to be determined. Is right. So this is your north pole. You can check it, and this is the something like you can see axis of rotation. It is rotates like this. Okay. Now these are the flux density. B is equal to theta by A. This is we can call a pi by A. Rather, I can say that's flux by the magnetic field divided by area of cross section. Right. So you can see area A is a conductor of length L is placed in a magnetic field of pi Webers. Okay. Uh, in a square meter, which A is a square meter, so that the flux density B is equal to pi by A. Okay. The conductor is rotated about the axis with a velocity of V meters per second. Due to that, the conductor rotates with a velocity of V meters per second. And if you want to find out the electromotive force or voltage generated at any angle, you can use this formula. E is equal to BLV sin theta. And since it is number of coils are going to have this electric motor, therefore you can see E is equals to 2n BLV sin theta volts. Right, this is the equation you will be using for electromotive force is concerned, or otherwise voltage is concerned. Okay, now, so as I said to you that there are different types of motors. They are going to be separately excited, shunt excited, brush motors you are having. Okay, so therefore we'll try to talk about those classifications here, right? Separately excited motor center. This is a motor connection. This is going to be field current, right? Or otherwise your magnetic flux connections, right? So here field winding and armature winding are supplied with separate source of electric power here. You can check it here. By independently controlling the field current, the speed and torque characteristics of a separately excited motor can be adjusted to meet specific requirements. This type of motor, this separately excited motor, specifically used, offers a good speed regulation and can be easily controlled by varying either armature voltage or field current. Either you voltage armature current or field current, you can able to change this one speeds, right? And separately excited motors are commonly used in applications that require precise speed control, such as industrial machinery, robotics, electric vehicles, and various automation systems are concerned. Okay, this is about the representation of your separately excited DC brushed motor is concerned. Okay, and shunt excited DC motor is going to looks like this one. Here, these are no how it is connected. You just check it, right? So here uses a parallel combination of field winding and armature windings to generate rotational motion. The term shunt refers to the way the field windings is connected in parallel with the armature winding. Okay, in parallel with the armature winding. Right, the field winding is connected across the supply voltage. The field winding is connected across supply voltage, allowing it to receive constant voltage. This creates a magnetic field that remains relatively constant regardless of changes in load and speed are concerned. Right? The armature winding, on the other hand, carries the current that produces torque, torque and rotation. It offers good speed regulation and can be maintained its speeds even under varying loads also. It offers good speed regulation and can maintain its speed even under varying load conditions also. It tries to maintain the speed regulations. Okay. And next one is series excited DC motor. Series excited DC motor looks like this one. Okay. This is seriously connected one. Okay. Field winding is connected in series with the armature winding. This is armature winding. This is winding. This means that the same current flows through both the field and the armature windings, resulting in a strong magnetic field that provides high torque at low speeds. When you want to have a high torque at low speeds, they go for the series excited DC motors are concerned. Okay, series excited DC motors are commonly used in applications such as electric vehicles, cranes, and elevators. However, the drawback is there. They can be prone to speed regulation issues and require additional controls for this kind of arrangement is concerned. Okay. This is compound excited DC motor is concerned. Okay. Next. Yeah. Another one is permanent magnet brush DC motors. You can just now I mentioned shown to you the video is related to that one. And then brushless DC motors. I'll try to talk about this. Also, we discussed about this, brushless DC motors. And one of the advantages you are having is nothing but brushless DC motors typically have a efficiency of 85 to 90%, whereas brushed DC motors have a 75 to 80%. And where you cannot use this brushed DC motors also in the video I have shown to you. So I am not going in detail about this one also. Okay. Next, coming to the brushless DC motors as mentioned as two types of brushless DC motors, outrunner and in-runner type of brushless DC motor, BLDCs. Just I am trying to show you the pictorial view or otherwise how the arrangements looks like this. I'll try to show you here, right? In-runner and outrunner. If you see here, this all the arrangements here, I'll try to talk about this one. The outrunner, the exterior rotor and interior stator is there, right? In outrunner, this is right. This one, if you see it, exterior rotor and interior stator is there, right? Configuration characterize this type of motor, also known as hub motor. This also we call it hub motor. The wheel is here. You can see this wheel is directly connected to the rotor. The wheel directly connected to the rotor, eliminating the need for external gear systems. In some cases, it may have built-in planetary gears also. Okay. So it means this outrunner can directly, you can connect it to the vehicle. Okay. That is the advantage you are having. Okay, this type of vehicles are you found in three-wheelers or something like, right? This design reduces the overall size and weight of the vehicle. This design reduces the overall size and weight of the vehicle and is favored by electric cycle manufacturers such as Hulical, Prongs, Sparrow, and light speed bicycles as two-wheelers manufacturers like 22 Motors and NDS Eco Motors. They have manufactured this kind of it. You just observe this diagrams and pictorially how this is shown to you, right? This is in runner configuration, right? The rotor is inside. This out runner configuration is see. Okay. All right. So in runner configuration, the rotor spins inside a stationary store. This rotor spins inside a stationary store. The BLDC motors are commonly used by three-wheeler manufacturers like Goenka Electric Motors, Spigo Vehicles, Kinetic Green, Volta Automotive, and low to speed performance scooters also they use such kind of arrangement. You can see this arrangement of it. Okay. Yeah. So advantage and disadvantage we'll try to talk about it. Okay. The primary drawback is the high cost associated with using permanent magnets in case of permanent magnet dismounts. So overloading the motor beyond a certain limit reduces the life of permanent magnets due to thermal conditions. This just now it is talked about the permanent magnet kind of thing. Okay. Now, next advantage of DC motors electric vehicles are going to be high efficiency, high torque, regenerative braking is possible, simple control systems. High efficiency means DC motors have high efficiency which can reject in longer range and battery life for EVs. High torque is provide high torque at low speeds, which can means that is low speeds. You know, we mentioned series type of DC motors, which can improve the acceleration performance of EVs. Regenerative braking is nothing but kinetic energy of the vehicle. When you apply the brake, the kinetic energy of the vehicle can be converted into electric energy and stored in the battery for later use. And the DC motors advantage is going to be reduce the complexity of the EV's electric systems. There are some other disadvantages. It is naturally because advanced technology is normally costly and limited speed range you are having. Maintenance is a problem and limited availability is available. These are some of the advantages and disadvantages of it. Okay. And coming to AC motors, AC motor configuration is like this. Okay. This is AC motor configuration. You can able to see it. It is typically comprised of two main components: an outer stator with coils. These are outer stator with coils. Receive AC to generate a rotating magnetic field and an inner rotor affixed to the output shaft that creates another rotating magnetic field. The rotor's magnetic field can be generated through permanent magnet, reluctance silency, or DC or AC electrical windings. Okay. The construction looks like this. They have the frame, stator, the rotor, and bearings, fan, shaft, and end belts. Working principle is just like what we discussed in DC motor, the same working principle. The working principle of an AC motor is based on electromagnetic induction, what we discussed about it. When an AC is applied to a stator windings, when AC applied to stator windings, right, it creates a rotating magnetic field. This rotating magnetic field induces a current in the rotor winding. The interaction between the stator rotating magnetic field and the rotor's induced current creates a torque that rotates the rotor. The speed of the rotor is determined by the frequency of the AC given to the stator and the number of poles of the stator. The higher the frequency or the more poles, the faster the rotor will rotate. This is about the principle of the AC motor. And here there are three types, I said: permanent magnet motor, and again induction motor is there, and another one is going to be switch reluctance motor is there. So I'll go to that. Yeah. So the principles you know about it. I'll try to talk about squirrel injection motor. The most common type of AC motor used in EVs is going to be the squirrel induction motor. They are reliable, efficient, and relatively inexpensive. Squirrel case induction motors work by using a rotating magnetic field to induce a current in the rotor. And this is, you can check this. This is a diagrams related to it. And again, the advantage of induction motor, I will talk about it. It is going to be cost less expensive than synchronous motors. Simple design it is having. High reliability. High reliability is going is the advantage of induction motors are concerned. Disadvantages of induction motors are going to be lower efficiency, limited torque, no regenerative braking, more complex control systems are there. Next, I'll go to that. Yeah, this is okay. Okay, this is okay. Yeah, this is a kind of switch reluctance motor is concerned. Okay, uses the principle of reluctance to generate torque. Unlike other types of motors, switch reluctance motors do not use permanent magnets or windings on the rotor. The rotor has a series of salient poles that align with the stator poles when energized. This is a construction of your switch reluctance motors are concerned. Okay, reluctance is nothing but which is resistance to magnetic flux. Something we try to talk about it. Yeah, this is about the different types of motors what you are having it. And now I'll show you one more important topic which I wanted to talk to you. Yes. Whether my screen is visible?
No, sir. No, sir.
My screen is visible, the PPT.
No, sir. No, sir.
I've shared already. Now okay? Is it fine?
No, sir. Still we cannot. We cannot. It's complete blank. Blank.
Still blank. Oh, one minute. 1 second. Now?
No, sir. Still nothing.
Okay, 1 second. Yeah. Now hope you can see it.
Yes, sir. It is.
Yeah. So here, a small information I just want to talk and then I'll close it. Okay. So this is the arrangement you are having. This is a motor, right? And it is the supply you are giving it, right? Current you are passing to it. Okay. Now, when you want to calculate VA, right? This is equal to E plus IARA, right? And E, this is right. It demands is going to be E is equal to KE pi omega n, and the torque developed is equal to T is equal to this. These are constants, right? Pi into IA. Okay. Now, when you want to find out the torque developed is equal to, this is the equation they are using it. Okay. Now, uh, when you draw the speed characteristics with respect to different types, what we discussed earlier, this is the torque versus speed. You can have no separately existed DC motors, exactly vertical line, linear line you can have it, and series you can check it here, and then compound you can check it here. Okay, are you following? So here, if you see, this is single quadrant chopper fed drive. Means what? If you this I'll skip it here and I'll show you one more diagram here. See, this is first quadrant, second quadrant, third quadrant, fourth quadrant. If the arrangement is there in first quadrant, means forward motion. Means that here voltage is positive, sorry, current is positive as voltage is positive. And when it is in second quadrant, it is going to be the voltage is positive, whereas current is negative. And third quadrant is going to be both voltage and currents are negative, right? And if you go to the reverse braking, it is nothing but the current is positive, voltage is negative. So this kind of arrangements are there in case of a control device, you can call it as, okay? So this is about the last topic which I wanted to talk to you. Yeah. So with this, I'll exactly stop at 7:20. I'll take some clarifications from you, doubts I'll take from you.
Your participant
Srinivas Reddy garu?
open for Q&A now.
Hello?
Sir.
Yeah, your voice is not. Oh, yeah. Now tell me.
Sir. And dear participants, the session is open for the questions now. You can please ask if you have any questions.
First of all, I express sorry for that. It is a topic of very lengthy. This topic I covered for a semester in the previous. All right. This is second time I'm handling this. I mean, the lecture which I'm trying to talk to you. It is my second time. Second, right? First, I have taught this in the classroom, and second one is online. That's all. So there are some the information which is missing, but I'm sorry, it is only 1.5 hour I give it is given to me. Uh, to convey that concepts only I shown that videos, not like no anything to extend the time or not like that. It is to show you the concepts how these principles will be followed in case of a DC motor working and in case of a brushless DC motor. And there are videos also for pulse width modulation in case of AC motor control. Those I have not shown to you. If time permits, I will try to show to you also. Yeah, any questions from the participants, I can able to answer it. I know for the electrical people, it is a primitive level.
Yes, sir. Hello.
Yeah, somebody is talking. I cannot able to hear it properly.
Yeah, sir. This is Dr. Prasad from
Yeah.
Godavari Institute of Engineering and Technology.
Yes. Yes.
Working there as an assistant professor.
A bit louder. Tan
Yeah. Yes, sir. Yes, sir.
Tankeshwar Prasad, right?
Yes, sir. Yes, sir.
Can you bit loud talk to me?
Now, are you audible, sir?
Yeah, now it's fine.
Okay, sir. So my doubt is here.
Yeah, can you introduce yourself, right? Which department you belong
Yeah,
to?
sir. I belongs to Mechanical Engineering Department.
Okay.
Godavari. I am working in Godavari Institute of Engineering and Technology, Mechanical
Okay,
Engineering
good.
Department.
Okay.
So my question is here. So in most of the electric vehicles,
Okay.
we use synchronous motor.
Yes.
So what type of DC motor we use here in electric vehicles in today's so many models are there, electric vehicle models.
Okay.
So
Okay.
which type of DC motor we use generally?
See, I can say I can say this is nothing but no the affordability, right? The more you require it, as different classifications I shown to you know, started from small DC motor which is of series connected, separately excited, shunt motor, combination of it,
Yes, yes, sir. So
right?
there are
And the
many
second case
motors you
also I saw.
explained. Yes, sir.
Sorry.
So you explained many different type of DC motors.
Yes. Yes.
So my doubt is here in most of the electric vehicle model,
Okay.
what type of DC motors are used?
Brushless only. Normally they go for
Okay.
brushless only. Just
Okay.
now I explained to you know the advantage it is having. Its efficiency is higher, 85 to 90 compared to the brushed DC motors which is having 75 to 80% only.
It's fine, sir. Thank you, sir.
Hmm. And thank you, Sir Prasad.
Yes, sir.
I shown to you outrunner, in-runner configuration also.
Yes, sir. Yes.
For two-wheeler, how it is, no, or three-wheeler, how it is looks like.
Yeah.
The last slide, I believe. Before I switch over to controls, I
Yeah.
shown to
Two
you the.
different type of motors also you can see. Just yes, network.
Are you talking to me?
No, sir.
Yeah.
My doubt is clear, sir.
Yeah. Thank you.
Okay. Okay, sir. Thank you, sir.
Next, anybody? My friend Babji.
Dear participants, if there are no further questions, then sir, we have a question from.
Yeah,
Hello.
somebody mentioned how much this. Just a second, I'll go through it. Sir, how much efficiency available in DC motor? I just mentioned, no, based on the two types of DC motors, one is 75 to 80%, another one is 85 to 90%. Brushless DC motors, as theory says, it is going to be 85 to 90%, and the DC motor, brushed DC motors has got 75 to 80%. See, you cannot carry AC motors on your vehicle, I believe, electric vehicle, because the battery is there, no? Therefore, battery, after that, there is a if you want to have no inverter, you can convert DC to AC, then you can connect it, okay?
Sir, good evening, sir.
Yeah.
Myself, Sheikh Naeem.
Okay.
Sir, I am audible now, sir. Okay, sir. So, I
Clearly.
am, yes, sir. I am assistant professor from Godavari Institute of Engineering and Technology.
Very good.
Sir, you mentioned that the efficiency, whatever just you mentioned.
Okay.
So, whether this efficiency can be increased by using optimal cooling system?
Might be, it is possible to cooling system.
So,
Means you are talking
what
about
type of
motors,
cooling
right?
system? Yes, sir. Motors. What type of
Yes,
cooling
yeah.
systems they are preferring, sir?
Yes, yes. So normally this is going to be no generalized cases, and based on this no power requirement again the temperature operation, the efficiency may go up or go down.
Yes, sir.
Okay.
But general, what cooling system they are preferring, sir, nowadays?
But I am not that much thorough about it. Okay.
Okay, sir.
I'm
Okay.
sorry for it.
Actually,
Okay.
we are talking no efficiency. The efficiency may depends on the temperature of the
No,
motor.
we just talked about the motor efficiency, right?
Yes, sir. Yes, sir.
No, other
So,
things are there. No, from motor to mechanical efficiency is there, right?
yes, sir. Yes, sir.
Those things, propulsion is there. Okay.
Yes, sir.
What type of drive mechanism you are using it for that? You have synchronous gear drive is there, different gear drives are there, no?
Yes, sir.
Torque converters, those things. I have not covered those things, okay?
Okay, okay, sir. Okay, sir. Thank you, sir.
What are parameters to be considered while selecting brushless motors for EV? So, for that, I just show you something information. Somebody asked it.
Sir, good evening, sir.
Good evening.
Sir, I am Selokkumar from Francis Engineering, Tirunelveli.
Yes.
So first of all, your PPT is very good, sir.
Thank you.
Sir, I am asking a simple question. What are the
Yes.
specifications available in the brushless DC motor, sir?
Okay. So,
If you are using for DC motor, I understand, sir.
yeah. Can you see my slide now?
Kindly give the specifications.
That's what I'm trying to show you that something like sizing of a DC motor.
Yes, sir. Yes, sir. Yes, sir.
Can you able to see?
Yes, sir. Yes, sir.
Yeah. So this is something like related to one. When you want to buy a vehicle, right? Two-wheeler, four-wheeler. How do you specify the vehicle? Is it a SI engine or CI engine? First of all, am I right? Hello. Hello.
Yes, sir. Yes, sir. Yes, sir.
Yeah, SI engine. Okay. And then the output, right? Power output. And the mileage, right?
Okay, sir. Okay, sir.
Yeah. In the same sense here, the sizing of the DC motor will play a role, right? Nowadays. Are you following? Yes, please.
Yes, sir. Yes, sir. Yes, sir.
Yes,
Yeah.
sir.
So this is ultimately this is the number 4. If you see motor power is equals to motor torque and motor speed.
Okay, sir. Okay.
Yeah. Can you able to see all of you, please?
Yes, sir. Yes, sir. Yes, sir.
This is low torque. How do you calculate low torque is equal to force into distance, right? Motor speed is equals to required linear speed. This is nothing but V is equals How do you R omega is there? No principle. V is equals to R omega. Based on they use it, torque is equals to load torque divided by gear ratio. The gear ratio you will be following, first gear, second gear, third gear, fourth gear, something like, right? This is a gear ratio, and then motor power is equals to this one. In fact, I just wanted to cover those things, but because I was not given the topic related to this one, they gave me that electric drives, I believe. Due to that, I have covered that one, and I tried to, since in the previous class some of them asked about hybrid electric vehicle related things. Just I throw some light on that hybrid electrical. What is the hybridization? How you define this hybrid vehicles in the different way based on the regenerative braking. You follow it, okay? So I hope I have not covered any high-fi topic. Just I have covered only the fundamentals, which are needed those who want to do some research on this. Okay, and the controls also I just collected some information like pulse width modulation and vector control and direct torque control. Something like for AC motor control are considered, and DC motor control also I showed some of the information, but I have not discussed those things here.
So thank you very much, sir, for the extensive coverage of the types of drives in EVs, along with the fundamentals. And you have clearly explained the working principles and the present day architectures which are available in the market also. So with this, we have come to the conclusion of session number 7 for today. Thank you very much, sir. So I extend
You're welcome.
sincere thanks on behalf of our institution.
Hope you can write to me any clarifications related or otherwise anything related to my research area. Okay. And you can see my website and you can find my publications also. You can refer my publications. I have publications related to this IC engines part, alternate fuels and engines. I have publications like fuel cells. I have publications like conversion of fuel cell into conversion of fuel cell propelled vehicle also. I have designed it, and we have publication related to that one. And I started working on PM fuel cells. I started working on SOFC also. Now at present I am working on carbon capture technology with the help of MCFC fuel cells. Okay, this is my research area. You can find my research areas on the website also.
Thank you, sir. Thank you for extending your helping me to the end researchers.
Yeah. See you again. Bye.
Thank you, sir. Bye, sir.
I'll sign out. Okay.
So, dear participants, now we will move ahead to our session number 8 on day 4. So the resource person for this session is Mr. P.V. Ramprasad. He has delivered a session on yesterday, that is date 3 also. I will, without any further delay, I will hand over the session to Mr. P.V. Ramprasad. So we welcome you, sir, Mr. P.V. Ramprasad. Sir, am I audible, sir?
Yeah. Thank you very much for having me again today. And am I audible for everyone? Is the voice clear?
Yes, sir. It is clear.
So clear.
Yes, sir. Audible, sir.
Okay. See, yesterday we had these charging infrastructures, needs and challenges. And yesterday we also tried to use the charging management system. I think one gentleman from Visakhapatnam was able to download the charger management system app, and he was able to start the vehicle remotely. I don't know if he is attending the meeting today or not. Are you there, sir? From Visakhapatnam yesterday. He attended from Visakhapatnam.
Yes.
Okay, thanks. Yeah, thank you. And any questions from the last class of yesterday? Any doubts you guys have? Okay, no issue. So without any further delay, I think this is the last session of the day, and many of you may be having a very, what you call a busy day. Probably, maybe, I don't know how your concentration levels will be there, but I'll try to present the topic as early as possible. We'll try to cover it by 8:30 or 8:40 so that you have some time for any questions, and then we can wrap up by 9 o'clock. Okay, today I'm going to speak about government policies and roadmap for green mobility in India. Government policies, be it central government of India or state governments of different states of India, we'll try to cover what are the policies, especially for Andhra Pradesh. And in general, we will also try to cover what are the different state policies and what are the type of incentives that are given for the different sectors of the economy. So actually, before we start the session, one small question I have for everyone here. Do we need any government policy to support transition of vehicles from ICE engines to low pollution emitting vehicles? Yes or no? Means why there should be. If anybody can contribute, why there should be any government policy at all? Anybody wants to, even if it is wrong, you can try. Why there should be any government policy? Okay. See, usually there are government policies. Yeah, Dr. Subramaniam Garu mentioned about FAME policy. Thank you, sir. What I'm basically asking is why there should be a policy at all. That was my question. So actually, there are a couple of reasons. Yes,
Sorry,
someone
sir.
was saying.
To regulate the global warming and climate conditions.
Thank you, madam. Excellent. Any other reason, madam?
And that's it.
Yeah, means there are a couple of reasons. I will try to cover those reasons. Because, you know, ICE engines is the abbreviation for internal combustion engines, which you guys are familiar with. ICE engines have been in the market for the last 150 years, whereas the new vehicles, whether it is electric vehicles or any other vehicles, or a hydrogen powered vehicle or a fuel cell vehicle, volumes are not there in the initial period of any vehicle introduction or any new technology introduction. So what usually governments do is to create a fair playing field, they give some sort of incentives for the new technologies. So government policy usually defines such sort of incentives that are usually given to vehicle manufacturers or individuals like us also. So when they provide some sort of subsidies or some sort of government policies, the vehicle cost, let's say, which is around 2 lakhs without any subsidy, because of the subsidy, the vehicle cost may reduce. I'm talking about a two-wheeler. Because of the subsidy, the vehicle cost will reduce to around 1.2, 1.3 lakhs for a two-wheeler, which is a bit higher than the ICE engine motorcycle or a scooter, but still it is in the affordable level. The policies and roadmap or whatever it is done so that in the initial period, let's say for the last 10 years, the government of India as well as state governments are providing these government policies as well as subsidies so that the bridge or the gap between the ICE engine vehicles and the new technology vehicles are very small, means the gap is reduced over a period of time. So what are the main drivers? What the main drivers we see from the central government as well as state governments of India is there are three main drivers. The government of India has given a high level target. What is the high level target? The government of India high level target is by 2030, 30% of the new vehicles that are being sold in the market should be of electric vehicles, means pure EVs. So you can imagine, let's say if the vehicles that are being sold per month are around 10 lakhs per vehicle. So by 2030, what government of India wants is they want to have 30% of such vehicles to be electric vehicles. And other reason, what is the third reason? Second reason. Second reason is energy security. Why energy security? Approximately $1 billion per day is being spent on fuel imports. So they want to reduce the import oil, means import dependency from outside India, so that our energy security is increased. All of you know about these tariff of America on India. It was 25%, and then again 25% has been levied for the oil being, because of the oil being procured from Russia. So those are the factors. Let's say India wants energy security or energy independence. So one of the things which makes it possible is having high number of electric vehicles on the road, because electricity can be generated within India using hydel sources or coal power plants or gas power plants or solar PV or wind energy. So they want some sort of high energy security so that our dependence on outside countries for our own basic needs is reduced. Another thing is which many people are afraid is if there is any sort of war again between India and its neighbor, there should not be oil embargo from the Gulf countries, let's say, which is exporting a bulk quantity of oil to India. So those are the factors, geopolitical issues are there, because of which government of India, irrespective of the party in power, they want to diversify their fuel mix. Then the third one, the last one, which is extremely important, is urban air pollution. Like one of the participants just answered, the CO2 emissions which happen in urban areas. So normally if you are stuck in a traffic jam in Bangalore or Delhi or Hyderabad, by the time you stay there for about 5 to 6 minutes, your noses and eyes starts burning because of the pollution that happens because of the ICE engines tailpipes. So these are the three main drivers which is driving electrification or diversification of vehicles from ICE engines to a hybrid engine or an electric vehicle or a CNG or a liquefied natural gas. There is another factor which is coming up quite recently is Dr. Subramaniam Garu mentioned about FAME. There is another terminology by the name CAFE. I'll just go to the next slide. Did anybody heard about CAFE norms? Anybody heard about CAFE norms? Or yes, means CAFE means, yes, sir. . Someone was commenting, yes or no, sir? Okay. See, CAFE norms, CAFE is the abbreviation for Corporate Average Fuel Efficiency Standard. So what do you understand by this? Corporate Average Fuel Efficiency Standard is for a vehicle manufacturer for four-wheelers. So here, Government of India has different stages. In stage 1, which was implemented from April 2013, the average CO2 emissions grams per CO2 per kilometer is less than 130. It has to be less than 130. And as you go to April 2022 onwards, the average CO2 emissions target has reduced, further reduced. What does that mean? The pollution, the CO2 emissions that are coming from the tailpipe of a vehicle has reduced from 130 to 130. That means that fuel efficiency has increased for the ICE engines. When you come to CAFE norm 3, norm stage 3, which is effective from year 2027 to 2032, there is a printing mistake there, sorry. It is written as 2022, but it should be 32, sorry. The average CO2 emissions grams per CO2 per kilometers has reduced to 91.7. So if you guys have time at any point of time, you can please download this CAFE norm stage 3 draft regulation, which is available in the websites, and have a look at it. What is different from stage 1 and stage 2? In stage 3 is there is something called as the derogation factors and super credits for electric vehicles, plug-in hybrids, and other low emission technologies. So the Government of India's policy is not restricted to electric vehicles alone. They are talking about electric vehicles. They are also talking about plug-in hybrids, and they are also talking about other low emission technologies like natural gas or liquefied natural gas or compressed natural gas. So such sort of fuels. So please, if you guys have any at any point of time, please download the CAFE norm stage 3 and kindly review. It is very interesting document. You will find out new things in that particular document. As you can see, the CO2 emissions per kilometer has reduced over 2017 onwards to 2032-37, which is further going to reduce by 70%. 70 means grams per CO2 per kilometer. So what Government of India is expecting is, they are expecting that there will be an increase in fuel efficiency. As you can see, the fuel consumption, the third row of the table, the fuel consumption liters per 100 kilometers, it is reducing. It was around 5.5, it has reduced to 4.78. In stage 3 and 4, they have not given any norm here, but they have given CO2 emission gram CO2 per kilometer. There is a standardized formula based on which weighted average of the vehicle manufactured by the manufacturer is calculated based on a set formula. So another variation what we see is among the CAFE norm stage 1, stage 2, stage 3 and stage 4 is testing method. The testing method is MIDC right now, which is modified Indian driving cycle. If anybody has time, please research on this MIDC, which specifies what is the different speeds at which a vehicle has to be driven to arrive at a liters per kilometers. So that is defined by testing method called as MIDC. Whereas if you go into CAFE norm stage 3 and stage 4, they are transitioning to an international standard, which is WLTP, which is called as Worldwide Harmonized Light Vehicle Test Procedure. So slowly, as you can see, the performance of the ICE engines is increasing, as well as the mix of the vehicles that are available in the market is also different compared to 10 years before. 10 years before, we did not have electric vehicles, we did not have strong hybrids, and we did not have, let's say, we used to have LPG fired cars, but nowadays you can find even CNG, compressed natural gas cars also available in the market. Now we talk about the government policies, central and state government. What are the different policies here we can see? There are something called as demand incentives, charging infrastructure incentives, and industry incentives. So the policies of Government of India and state government complement each other. Means state governments have their own policies and central government also has their own policies. But both the policies are trying to achieve transition of ICE vehicles, transition of purchase choices available to the consumer. They want the consumer to move away from ICE engines to a EV or an alternate technology, so that they are able to address certain core issues, especially the urban air pollution. Especially if you are in Delhi region, I don't know if there is any participant from Delhi region. Huge pollution, and there is a huge pollution issue, especially in the months of November to January, because of winter season as well as stubble burning. I think many people may be knowing, after the harvesting is complete, normally in Punjab and Haryana area, they try to burn the crop, because of which the air quality is very bad, especially in the northwest part of India as well as Pakistan as well. So like Dr. Subramaniam Garu mentioned, he mentioned about FAME policy, which is one of the acronym for faster adoption and manufacturing of hybrid and electric vehicle schemes. So this started in the year, FAME 1 started in the year 2015 to 2019, and then it was not that successful. It was transitioned into FAME 2. It was between 2019 to 2024 with an outlay of 11,500 crores, wherein using this budget, around 6,862 electric buses were purchased for the state transport organizations as well as government entities. 1.64 lakh three-wheelers were purchased using the subsidy that was given. 22,548 cars were given, including strong hybrids. And the maximum transition, means maximum amount of number, was seen in the two-wheelers, which is around 14.28 lakh vehicles. Actually, even I am one of the beneficiaries of the FAME 2 subsidy, because in the year 2022, I took one electric scooter using the FAME 2 subsidy. When you are using the FAME 2 subsidy, usually the Aadhaar card of the person who is going to purchase the vehicle is taken, and an OTP is received in your mobile number to ensure that the subsidy is provided to the person who is purchasing the two-wheeler. And only restriction that was there during this period is, can anybody tell what was the restriction? Anybody can tell what was the restriction in FAME 2? Can I buy two vehicles, two-wheelers? Okay, so during that period, what the government of India did is, they ensured that each person is entitled for subsidy claim of one only. So if I have taken one electric vehicle, I'm not entitled for another electric vehicle. So if I need to have one more electric vehicle, I had to use the Aadhaar card of my family member if I needed to purchase one more electric vehicle. So FAME 2 is complete in 2024, and now FAME 2 has been replaced by something called as Electric Mobility Promotion Scheme, which was launched in the year 2024. As you can see, the initial subsidy quantum was very high, 11,500. Now it has reduced to only 778 crores. The reason, we had talked about the reason in the starting time of our presentation, wherein we mentioned that because the gap of cost between the ICE vehicle and an electric vehicle was very high during the initial phases, because of which the quantum of subsidies that was supposed to be given was on the higher side. Plus, it was like a push. There was a push from the government of India so that the consumer buys an electric vehicles. Now it has become a pull market, in the sense like the push phase is over from the government of India side. Now automatically people are going for an electric vehicle because of couple of reasons which we have discussed yesterday. Now the quantum of subsidy has reduced. It is only 778 crores, and the subsidy is given in this following manner. It is restricted to rupees 5,000 per kWh. When we say 5,000 per kWh, kWh refers to the battery capacity. So let's say if I am having a Ola scooter, the 5,000, if I'm having a Ola scooter, the battery capacity can be 2 kWh or 3 kWh or 4 kWh. But what government of India is saying is, irrespective of your battery capacity, the maximum ceiling of the incentive for a two-wheeler is 10,000. Means they are only giving 10,000 rupees incentive per two-wheeler. And what is the number of two-wheelers that are being provided? The total number is 580,000 scooters or two-wheelers or bikes or scooters. So once this target is achieved, 580,000 numbers have been sold. That is the cap, after which the subsidy is no longer available. The next category is e-rickshaw and e-cart. The maximum number of vehicles it is going to support, the budget that is going to support is 13,590, and the maximum eligibility is 25,000 for a three-wheeler. And then again, there is a different three-wheeler. We call it as L5. Like you might have seen on the road, blue and white color autos, Mahindra Trio or Bajaj Go. They are under the L5 category. The number of L5 category is 47,119. And the maximum subsidy for such vehicles is 50,000 per three-wheeler. And there are other policies also. The first slide, what you have seen here, these fall under the category of demand incentive. Demand incentive means direct subsidy that is being given to the consumer so that he goes for an electric vehicle. These are the other government of India policies which are being implemented so that auto manufacturers also switch from ICE to electric vehicles. There is something called as PLI. PLI means Production Linked Incentive Scheme for automobile and auto component industry in India. This was launched in 2011 with a budget of approximately 26,000 crores. And this is usually given to manufacturers who achieve a domestic content of 50%. So if the vehicle value is, let's say, 1.5 lakhs, X showroom, the government of India expects that 50% of it, let's say if the vehicle cost is 1.5 lakhs, at least 75,000 there should be domestic value addition. Right now in India, the battery cells are imported from outside India, mostly China. Except for one manufacturer, I think Ola is trying to manufacture the battery cells within India. Other than Ola, we don't find any battery cell manufacturers in India who use lithium-ion technology. Of course, you see lead-acid batteries being manufactured in India, but the issue with lead-acid batteries is the depth of discharge in a lead-acid battery is approximately 45 to 50%, whereas in a lithium-ion battery cell, the depth of discharge can be as high as 80 to 90%. And then the next scheme is PLI, Production Linked Incentive Scheme for Advanced Chemistry Cell Battery Storage. This also was launched in 2021 with an approximate budgetary outlay of 18,100 crores. This is more specifically focused on battery manufacturing in India. Then comes PM E-Bus Seva Payment Security Scheme. Then again, around 3,400 crores has been deployed for purchase of electrical buses. Around 38,000 electrical buses are going to be purchased under this particular scheme. Means the objective is to ensure transition of the state transport authority buses from a diesel bus to a electric bus. The next one is a scheme for promotion of manufacturing of electric passenger cars in India. This was notified in 2024, and the only condition in this is they have to invest approximately 4,150 crores so that they are eligible for a subsidy. Then again, there is one more scheme by Government of India. Herein what we are speaking is, if you see the value chain here, first one is vehicle is being produced and given to the manufacturer and given to the consumer by a direct subsidy. And for the manufacturer, these are the different incentives that are provided to manufacture an electric vehicle. These two things are fine. What is the third element which is required is the charging infrastructure. If you are using a ICE vehicle, internal combustion engine vehicle, you will find petrol stations spread across nook and corner of India. So the only problem with electric vehicles is you can buy an electric vehicle as long as you have a charging facility in your home, it is fine. But when you want to travel outside your city, there is not much of a charging infrastructure. So what Government of India has done is they have brought out a special scheme by the name of PM E-Drive scheme, wherein around 10,900 crores have been provided for providing charging infrastructure as well as two-wheelers, three-wheelers, e-ambulances and public charging stations. And one other component they are supporting is upgradation of vehicle testing agencies. So what is in PM E-Drive? Let us specifically see what is there in it. Did anybody hear about PM E-Drive, or this is the first time you are hearing? Okay, so in the PM E-Drive, there is 2,000 crores has been specifically given to for establishing charging stations. So 2,000 crores is a very big number, which is being provided as a subsidy to the state governments as well as central public sector undertakings or state public sector undertakings. So it is supposed to be implemented in this financial year FY26, and the nodal agency is BHEL. Everybody must be familiar with the BHEL. So BHEL stands for Bharat Heavy Electricals Limited, to aggregate the charger demand and develop a unified EV super app for users. So like yesterday we have discussed, there are many apps which are being used by electric vehicle owners. So at some point it becomes like a pain point, because in your phone, in your smartphone, the number of apps, charger management system apps, can run up to 18 to 20 numbers, which can be a big headache. So what Government of India is doing is they have given the project management responsibility of building the EV charging infrastructure in India to BHEL as one nodal authority. And they have also given the responsibility to BHEL to develop a EV super app, so that any consumer can use the super app to go and charge his vehicle from any charging station in India. So what is there in the scheme? In the scheme, 72,000 chargers are to be deployed, around 22,100 fast chargers for cars, 1,800 charging stations for buses, and around 48,400 chargers for two-wheelers and three-wheelers. To accelerate the adoption of PM eDrive scheme is providing subsidies for building EVPCS. EVPCS stands here for Electric Vehicle Public Charging Station, and the percentage of subsidy for the different categories is as in the table below. If I want to install a charging station inside a state government or a central government facility, Government of India is proposing to give 100% subsidy on upstream charging infrastructure and 100% subsidy on electric vehicle supply equipment. When we say electric vehicle supply equipment, it means electric vehicle chargers. So if I'm a state government entity, let's say I'm a municipality, I'm a hospital, I'm a government educational institute. So if the government entity comes forward, the Government of India is ready to give you 100% subsidy for upstream infrastructure like transformers, switch gears, and all sort of things, and 100% subsidy for the electric vehicle chargers also. So it's a golden opportunity. If anyone is there from a government engineering college here, please pursue this with your management, with your principal or a vice chancellor, to look into this particular aspect so that you can take full benefit at zero cost. I repeat again, at a zero cost, you can install a charging station inside your university or inside your engineering college, if it is a government-owned college. The second one is highways. Like we discussed yesterday, we talked about destination charges as well as transit charges. So if it is to be, let's say, to be installed at a metro station, or it is to be installed as a bus station, airport, railway station, again, Government of India is providing 80% subsidy on the upstream infrastructure. When we mean upstream infrastructure, it means transformers, switchgear, cables, and all sort of things, and 70% subsidy on electric vehicle supply equipment. All other locations like cities, shopping malls, market complexes, Government of India is saying that, okay, we have given everything to the state government, central government, public sector undertakings, state government, public sector undertakings. What is for the private sector? So the category C covers the private sector, which says cities, shopping malls, market complexes. If you want to install a charger inside such places, we will provide you 80% subsidy on the upstream infrastructure. Now, this is all fine. 100% of what? Many of you might have thought, yeah, what is this 100%? If I spend 1 crore, will they give me 1 crore? Next slides provides you the detailed information. So these are the benchmark figures. So when they say 100% subsidy, what are the caps? These slides provides you that information. So if upstream infrastructure we are talking up to 50 kW load or power connection, they are going to give us 6 lakhs, which is if I'm a state government or a central government entity or a government hospital or a government college, I'm going to get these numbers 100%. So if I'm having a 150 kW separate connection for electric vehicle charging station, Government of India is going to give me 19 lakhs. So the cap here is 24 lakhs is the maximum amount you can get for a single location. Then again, electric vehicle supply equipment. Right now, Government of India has given benchmarks for only 2 types of chargers. One is up to 50 kW DC charger, 7.25 lakhs, and 100 kW CCS2, again a DC charger, it is 11.68 lakhs. So it's an excellent opportunity for government college, engineering college facilities. If anybody is there from a government engineering college, they can take a note of this and they can try to pursue it. So I'm now going to specifically talk about Andhra Pradesh. This will be valid for other states of India as well. What they are saying is, if I want to install in Andhra Pradesh, okay, these subsidies are available. Everything is perfectly fine, but where is it allowed to be installed? So first thing is smart cities. Smart cities, as you know, there are smart cities in every state of India. In Andhra Pradesh, there are 4 smart cities. They are Amaravati, Kakinada, Tirupati, and Visakhapatnam. So there is a capital city of the state. It is Amaravati right now. And there are NCAP cities, National Clean Air Program cities. These are the NCAP cities. They call it as NCAP cities. The fundamental of NCAP city is they want to have less amount of air pollution there, because of which there is an incentive for installation of electric vehicle chargers in these particular cities. In Andhra, these are the different cities that are allowed and under NCAP eligibilities: Anantapur, Chittoor, Elur, Guntur, Kadapa, Kurnool, and other places. Some of the things are you will find the presence in smart city also and NCAP cities also. So especially if my city is there, Rajahmundry, where I live, where I operate from, it is covered under NCAP city. Other than this place, state governments can also select some other place and suggest to Government of India. The next is highways are over. Cities are over. Next is highways. Highways can be places on interstate highways to be chosen in consultation with MORTH, which is Ministry of Road, Transport and Highways, Government of India. Their focus is to install on highways with a high vehicular volume. Let's say, for example, between Chennai to Vijayawada, Vijayawada to Visakhapatnam, Visakhapatnam to Bhubaneswar, those sort of national highways, which has very high vehicular volume. Highways that connect major cities, industrial hubs and ports, and other parameters as recommended by nodal agencies. Now, until this particular place, we have seen what are the Government of India policies. Let us recap one time what are the different policies of Government of India. First one is like Dr. Subramanian Garu said, FAME, which was previously there. Then there is e-mobility scheme, e-mobility promotion scheme. Then there are production linked incentives for automobile manufacturers, production linked incentives for battery storage, advanced chemistry cell battery storage, PME bus seva, and promotion of manufacturing of electric vehicle passenger cars. And then there is PME drive, and we have seen what is there in the PME drive. These are on the central government policies side. Let us see what are the policies on the state government side. So this is the map of India, wherein the different, it shows. Is this map clear to everybody? Is it shown clear?
Yes, sir.
Green says that there is a notified policy, and blue says that policy is in the draft stage, and gray color shows that there is no policy in that particular state. So as you can see, most of the states in India right now are having a policy, a defined policy, except for a very small number of states like Jammu and Kashmir, Bihar, Sikkim, and some other states in, except one or two states in Northeast India, most of the states are have a notified policy or there is a policy in the draft stage. Now let us see what are the state government policies. So like we mentioned, like we spoke previously, these are the three sort of incentives that are provided by state governments: demand incentives, charging infrastructure incentives, and industry incentives. Let us see each one of them now. State government policies, demand incentives. So there is demand incentives as well as disincentives also. So let us see what are the demand incentives. Incentives are a thing which are provided to increase the consumption. It acts as a catalyst. If any chemical engineer is there in this group, we know what a catalyst is. What is the function of a catalyst in a chemical reaction? It enhances the speed of the reaction. Similarly, demand incentive are provided to the consumers so that they switch to a particular choice, which is shown by the different governments. What disincentives are? These are the inhibitors which are placed so that the consumption or adoption of a particular thing reduces. So first demand incentive is purchase subsidy. So when we say purchase subsidy, some of the states are giving purchase subsidy for buying vehicles. Many of the states are providing subsidies for purchase of electric cycles. Some of the states are providing subsidies for purchase of three-wheelers. So direct subsidy, they will give an amount, let's say 5,000 rupees for a purchase of electric cycle, or a 10,000 rupees for purchase of a three-wheeler. Then the second thing is road tax exemption. What do you mean by road tax exemption? When we buy a vehicle, when we go to the Road Transport Authority to register our vehicle, there we pay something called as life tax. So if you are buying an electric vehicle, some of the states don't have any road tax. For example, if I buy an electric car or scooter or an auto or a truck in Andhra Pradesh, there is no road tax. Scrapping and retrofitting exemption. What does it mean? Scrapping means some governments, especially National Capital Region of India, gives some subsidy for scrapping and retrofitting. Means you scrap your old vehicle we are going to support you. EV financing. EV financing is governments are giving something called as interest subvention. Did anybody heard the word subvention? What it means is, if the interest rate, corporate interest rate, when you buy a vehicle from a particular agency and then go to a bank to get some sort of loan, it will be around 9% or 10% based on the interest and based on the loan amount, based on the tenure you opt for. What government of Delhi has done is, they said that we are going to take 5% of the interest on our head. Means if I am going to pay interest of 9%, the government of Delhi will pay 4% of 5% as interest subvention, and other 4% is paid by the consumer. So this is given by Delhi state government. And then there is free permit. What does a free permit mean? Does anybody know? Anybody knows what a free permit means? Normally, if I am having a three-wheeler, the permit is given for a particular district or a particular area. If I am buying a ICE vehicle, ICE auto. Whereas if it is a electric auto, some of the state governments have given free permit. If you are having an electric vehicle, you can ride it in any part of that particular state. Then there are parking incentives. If you are parking a car in a public place, if it is a green plate, if it is a green vehicle or an electric vehicle, there is no parking fees. Toll fee waiver. In some of the states like Jharkhand and Chhattisgarh, if you are having an electric vehicle in some of the highways, notified highways, there will not be any toll fees. Then there is green zones. What does green zone mean? Any idea? Green zone means an area wherein only certain category of vehicles are allowed. For example, let's say in some of the tourist places, they allow only battery operated vehicles. Especially in airports, you might have seen only battery operated vehicles are there inside the arrival and departure places. Then we talk about disincentives. What are disincentives? There are two types of disincentives. One is applicable at the time of purchase, and other one is applicable while you are using your vehicle. ICE cess. For example, if you want to buy an ICE vehicle in Andaman, there is a cess. Means when you are buying, you have to pay extra 1% or 2% as a cess because you are going for an ICE vehicle. So it is like an inhibitor which stops people when they are comparing the cost. Okay, my electric vehicle is around 1.1 lakh. If we see my ICE engine, it is around 98 to 1 lakh rupees, including the cess. So that sort of comparison or that sort of inhibition is created in the market so that people are discouraged to buy a particular category of vehicle. Then there is fuel cess. Fuel cess. So fuel cess is there in Delhi, wherein there is certain amount of percentage collected from every time you fill your diesel, there is a cess imposed, and that cess is being collected and put into a pool by the name as EV pool, which is again used to which is again used as a fund to give to the consumers. Let us see what is there in government of in the state of Andhra Pradesh. In the state of Andhra Pradesh, there is purchase subsidy is there. If I buy an electric vehicle, there is no, there is purchase subsidy, but the clarity is not there. How much amount is being by government of Andhra Pradesh? It is there in the policy, but we have not seen its implementation on the road. Then road tax exemption in Andhra Pradesh, it is 0. And then scrapping and retrofitting exemption, whether it is there in Andhra Pradesh or not, it is not there. EV financing, it is not there. But if you are from an SC, from reserved community, there is some sort of financing available for certain sections of population. Free permits, there is no free permits. Parking incentives are also not there. Toll-free waiver is also not there. Green zones, they are planning to do it, but they have not notified which places are defined as green zones. Then comes the state government policies. The next thing what we discussed about in the initial slide was charging infrastructure incentives. Government of India is providing incentives under PME drive, as we have talked about it previously. And state governments are also providing incentives for creation of charging infrastructure. What are the different incentives? Let us see. Capital subsidy. Capital subsidy means they are providing incentives for installation of charging stations by the state government. In Andhra Pradesh, they are giving 25% capital subsidy up to 3 lakhs maximum for 5,000 public charging stations. So if I install a charging station in Andhra Pradesh, I can get a subsidy of up to 3 lakh rupees maximum. And that is limited to 25% of the capital cost, which is spent on charging equipment only. Whereas Government of India is giving a subsidy both on the charging infrastructure as well as charging equipment. Government of Andhra Pradesh is only giving capital subsidy for the charging equipment only. So 25% capital subsidy is there up to 3 lakh maximum. I am running a charging station business. I'm yet to get this benefit. Last time when I spoke to the nodal authority of Andhra Pradesh, they said that the guidelines and the framework is being prepared. We are hoping that we are going to get some part of this 3 lakh rupees. And that is limited to the first 5,000 public charging stations built in Andhra Pradesh. Then building regulation. Again, in the building regulations, different state governments are also coming up with some sort of a regulation. What should be the number of charging points that have to be provided in the building? In Andhra Pradesh, all new permits for commercial complexes, housing societies, and residential townships with a built-up area of 5,000 square meters and above will mandate charging stations. So all new permits, that's what Government of Andhra Pradesh says, means that policy came in 2024. So any new permits which for commercial complexes, housing societies, and residential townships with a built-up area of more than 5,000 square meter, you are, by law, you are supposed to have a charging station or a charging facility inside the complex. Concession on EV charging tariff. So normally what happens is in India there are around 60 distribution companies. Distribution companies can be state-owned or can be private parties or societies. So what they are doing is they are providing concessional tariff for EV charging stations. In Andhra Pradesh, it is around rupees 6.7 per kVAh for charging stations. Means that is flat tariff. There is no two-part tariff. If any commercial facility is there, EV public charging station is a commercial facility because it is for profit, right? If I'm doing the business, I expect some profit. So in other commercial facilities, it is a two-part tariff. There is a demand charge and there is a consumption charge. Whereas for a charging station, it is only a flat tariff. It is consumption based only. Next is renewable energy sources. In Rajasthan, what they are doing is, if your charging station is powered by renewable energy source, then you are given 50% rebate on the land that is purchased by the individual entrepreneur. Consumer interface of EV charging network. Again, this is somewhat cloudy. What it means, I could not understand, but means I think some sort of incentive is being provided for creating apps. So as you can see, in the state of Andhra Pradesh, there is capital subsidy, there is building regulation is also there, concessional tariff is also there. Renewable energy source, I think there is no incentive for it. Consumer interface for EV charging network, it is also not there. Then the next incentives which we normally see, what are the state government policies directed towards the industry. So up till now, it is directed towards the consumer. Means first one was consumer, second was charging infrastructure, third one is industry creation, capital incentives. Sometimes there are some sort of subsidies provided by governments, wherein capital incentives are being provided by the state government. Land development incentives. What are the charges that are being levied when you are developing a industrial estate or something like that? Then again, there are some sort of incentives there. Utility and concessional subsidies. When we say utility and concessional subsidies is, there will not be any duty. You must have seen your electricity bill. In your electricity bill of your home, there is something called as electricity duty. Means for each kW that is sold, government collects some sort of duty which is paid to the state government. It is collected by the distribution company and it is ultimately paid to the state government. So those sort of concessions are provided to the industries which are in this business of electric vehicles. Means if you are taking a connection for water, what are the charges for the water connection? What are the consumption charges? Those all subsidies are provided under utility and concessional subsidies. Then there is battery recycling initiative. Sometimes government of different state governments provide battery recycling initiatives wherein batteries are being collected and disposed of in a safe manner. Employment incentives, if you create X number of employment in a different place, there again there is an incentive. Skill development incentives, if you want to create a skill development facility, then there is again a skill development incentive is provided. I think Godavari University is having a skill development center, right, sir? Yes. Within the same university complex, there is a skill development center. Again, there is state government support for establishment of a skill development center or specific programs which are conducted by the skill development center. Suppose, for example, training students on electric vehicles or training students on design of electric vehicle components. Then there is again R&D initiatives are also there, means incentives for R&D initiatives. Some special programs are there wherein you can submit your initiative and can get some sort of incentive from the state government. This is about it. These are the different central government policies and state government policies. I thought we will wrap up a little bit early today because it is the last session of the day. If there are any questions from any of the participants, I'm happy to answer them.
Sir, myself Sheikh Naim, sir.
Yeah, yes, sir.
Yes, sir. I'm assistant professor from Godavari Institute of Engineering and Technology.
Yes, sir.
Sir, actually my question is, if what happened if 80% of conventional vehicles was replaced with a electrical vehicle? So then the demand of consumption of electricity is increasing, no, sir? Then what will happen? What will happen? Whether we are have sufficient power generation to run those type of vehicles?
Yeah. Actually, Sheikh Naim,
Yes, sir.
it's an excellent question.
Yes, sir.
And what state government and discoms are doing is they are trying to assess how much is the power required when you convert the entire IC engines, like you said. Let's not say entire. Let's say 80% of the vehicles
sir.
are 80% of the vehicle are converted into electric vehicles.
Yes, sir.
Different models are being run. Actually, in India, there is no shortage of electrical power.
What happened if it will reach
That's
to
what
80%?
I'm coming, sir. I'm coming, sir. So even if you reach to 80%, there
Yes,
is
sir.
enough cushion available in the Indian power system, Indian thermal power system, to meet that particular demand.
Thermal,
For
it will
example-
again consume coal, no, sir? The
No,
thermal
wait.
power plants.
Yeah. Wait, sir. So actually, if you see, when we talk about this thing, let me come to this. First slide. So
Yes,
what
sir.
they are saying here is, Government of India is targeting optimistically 30% EV by 2030.
Yes, sir.
So what is not shown here in this slide is, Government
sir.
of India by 2030 want 50% of their capacity, 50% of their capacity by 2030 from renewable sources.
Yes, sir.
So what Government of India is planning is, they are saying, okay, we need 30% EVs by 2030. But how do we meet that particular demand? Again, like you said, if it again comes from coal,
Yes, sir.
not much of benefit, right?
Yes, sir.
So what Government of India is saying is, by 2030, let's say I have 400,000 megawatt or 500,000 megawatt.
Yes,
Out
sir.
of this 500,000 megawatt, 50% should come from solar, means renewable power.
Yes, sir.
It can be solar, it can be hydel, it can be wind, or it can be nuclear. So Government of India is already thinking ahead of the curve. So what they say is, even if you convert to 30%, which is very aggressive at this point of time,
Yes,
we
sir.
are ready to supply that much amount of delta from renewable sources if needed.
But they developed any schemes to cope up that development, the renewable development?
No, actually, if you see, in India, you have
Yes, sir.
power generation from coal, power
Yes,
generation
sir.
from gas, power
Yes, sir.
generation from renewable energy sources,
Yes, sir.
hydel, nuclear.
Yes,
So
sir.
what Government of India is doing is, they are slowly reducing the ramping up of coal power plants.
Yes, sir.
They are not stopping it, but they are
Yes, sir.
slowly reducing, because existing thermal power plants, plant load factor is around 50 to 55%.
Yes,
They are
sir.
not being utilized. So
Yes,
what
sir.
they are trying to do is, they are trying to encourage more and more private sector participation in the renewable domain.
Yes.
Again, one more thing which is happening in the renewable domain is renewable with battery. Means if you take renewable solar power, it
Yes,
is
sir.
available only morning 6 to evening 4 o'clock or 5 o'clock.
Yes,
So
sir.
what Government of India is doing is, they are pushing developers to go for battery energy storage.
Yes,
So
sir.
because of which solar plus battery or wind plus battery, it is able to cater to the future needs. So they are
But
pushing the developers to consider such sort of things.
But I heard about whether, sir, 1 second, sir. I heard about whether if you increase the batteries, so for batteries, the main source is lithium, no, sir, nowadays.
Yeah.
So the mining of the lithium also create huge pollution nowadays. I maybe heard that one. So that may be one of the drawback, no, sir.
Yeah. Sheikh Naeem, what happens
Yes,
is,
sir.
means around 15 to 20 years back, let's say around
Yes, sir.
19, this is 2025, right? When we were in
Yes, sir.
2020, same sort of argument was used for solar PV panels also.
Yes, sir.
What they used to say is solar PV panel is also being produced from silica, and it is creating lots of pollution. But
Yes, sir.
again, now we are 20 years, now we are in 2025. We have seen that still that argument is there, but
Yes.
solar PVs are like
Still in
they are
use.
accepted now.
Yes.
But you have a point. Whenever
Yes,
there
sir.
is mining activity happening, especially
Yes, sir.
rare earth mining is happening,
Yes,
there is
sir.
certain amount of pollution is created. But there are certain policies which are going to evolve over a period of time.
But
Any
we are
technology,
yes, sir.
any technology for that matter has some pollution involved in it.
Yes, sir. But we are shifting from IC to EV due to the main reason is pollution, no, sir.
No. See, there are
Main reason.
like you see, the main three reasons are here. Two reasons.
Yes,
Energy
sir.
security is also there. If I'm
Yes,
in
sir.
Russia, I'm in
Yes,
Saudi Arabia, or I'm in Emirates, United
Yes,
Arab
sir.
Emirates, or America, for that matter,
Yes.
they are sitting
Yes,
on
sir.
gold mines. Gold mine
Yes,
is
sir.
nothing but crude oil or gas,
Crude oil.
which is
Yes.
abundantly available there.
Yes.
Whereas for India, it's around 9 to 10% is only produced in India. The rest
Yes.
comes from outside India.
Yes.
So they are worried about the energy security. Means, for example, the crude oil is now around $65 per barrel. Suppose, for example, there is some sort of a geopolitical crisis.
Yes, sir.
Are we able to get enough oil to supply to the country?
No, sir.
So those are the other reasons which government is thinking. Means they have, for example, since you asked this question,
Yes, sir.
there are strategic reserves of oil in India. There is one in Kerala and one in Visakhapatnam, wherein in the caves, oil is being stored by government of India. So they are trying to see that if there is any geopolitical tension and we have zero import of crude oil, how many days we can survive?
Yeah.
In the existing scenario, we can survive around 30 days to 35 days.
Okay.
That is considering the existing mix. Suppose storage increases and the number of electric vehicles also increases. In place of 30-35 days, it can increase to around 40-45 days.
Yeah, we can increase the time.
So those are the strategic considerations government of India is thinking.
Okay, sir. Thank you, sir.
Yeah,
thank you.
Good evening, sir.
Yeah.
My name is Aruna, sir. I'm from Department of Automobile Engineering, Godavari Institute of Engineering and Technology, sir.
Yes, madam.
First, your lecture is very informative and excellent, sir.
Thank you, madam. Thank you.
I have a question, sir.
Yes.
Sir, we discussed government policies, central and state, na, sir?
Yes,
so these policies are same as other countries, or is there any difference between our country and other countries, sir, generally?
Yeah. I think this is a very good question, madam. Normally, if it is a European country, there are some sort of trust. I don't know if you people have heard about the terminology called as. Yeah, I don't know if you people heard about terminology called as net zero.
Okay.
So It may not be in exact these words, but what people are doing is they are giving some incentive in every country. They call it in a different terminology. They call it as net zero. Means
Okay.
the government of India has declared a net zero of 2070.
Okay.
Europe has declared a target of 2050 or 2040, different countries in Europe. So
Okay.
when you want to achieve that particular target, there are policies in place.
Yes.
It varies as country to country.
Yes, sir.
India, what happens is the consumer is not conscious about the environment impact of the different ICE vehicles. But if you go
Okay.
to a country like Netherlands, people are very conscious. They
Okay.
use cycles there.
Yes,
So
sir.
it depends from place to place. Means if you go to Norway, they don't allow any ICE engines to be purchased. So it can be in
Okay.
the form of an incentive, or it can be in the form of a disincentive. Like we
Okay.
were talking about the cess.
Yes.
So there are incentives plus cess, means disincentives. So it varies from country to country. But if you see, for example, you have a government of India policy FAME 2 or different production linked incentives.
Yes, sir.
Some countries like China has
Okay.
filed a case against India in WTO, World Trade Organization. What
Oh,
they are saying is you have given an incentive for your domestic manufacturer, which is creating an unfair playing field. So those sort of things also happen. So what being a democratic country, India cannot cannot withhold any information from the public domain. If there is a policy, it has to be shown in the public domain, whether it is state government or central government.
Yes.
But if it comes to some other states or some other countries, there can be some sort of haziness. What China does, nobody knows. So
Yes, sir.
there are especially if you are an oil-rich country, your policies are different. If you are a gas-rich country, your policies are different. But
Yes.
everybody is moving slowly away from the ICE engines. That is for clear. I hope I could answer your question.
Yes, sir. Yes, sir. Thank you, sir. Thank you for the
Thank you.
patience.
If there are any other questions, you can connect me on LinkedIn if anybody is having.
Ramprasad, sir.
Uh,
Sorry for interrupting you.
No problem, sir.
Sir. Actually, your answers are much more of course. Your seminar is very informative, and these answers are also having much more information, sir.
Yes, thank you, sir.
Thank you for your patience
No problem, sir.
explanation.
Thank
And
you.
I have one question, sir, and this is not a question, actually, just like a business deal. Okay. You are having a lot of practical experience, and you have a lot of knowledge in the contemporary issues and government policies. And one thing is actually we are watching the three different vehicles on the road. They are the traditional IC engine vehicles, electric vehicles, and hybrid vehicles.
Yes, sir.
We already know that the hybrid vehicles are much more eco-friendly than electric vehicles and traditional vehicles. But these hybrid vehicles are costly, and a lot of research is going on to bring down the cost. And but
Yes.
the hybrid, we are watching in case of two-wheelers, we are having the traditional IC engine two-wheelers and electric two-wheelers. But hybrid two-wheelers are, we could not find the hybrid two-wheelers, and they are not succeeding also. We want to do some research work on hybrid two-wheelers, sir.
Okay.
If you support us, together we can try to fabricate hybrid two-wheelers. Actually, some kits are available on the in the internet to convert a regular the traditional ICE engine vehicle into hybrid vehicle, but they are not giving better results. So, could you assist our university, the RenEV CEO? Could you please assist us in developing a hybrid vehicle, or it is not a good thought? What you suggest, sir?
Yeah. Thank you, Subramanian Garu, Dr. Subramanian Garu. I think there is Dr. Subramanian Garu is an automobile veteran, so he accepts that hybrid vehicles is the best vehicle, which is proven and which is eco-friendly also. And lot of disadvantages in electric vehicles are offset in a hybrid vehicles. That is what he wants to communicate, it seems. When you opt for a hybrid vehicle, you don't have any range anxiety. If I am having an electric vehicle, always I have a range anxiety on the back of my mind. When it falls below 20% of the charge, I'm worried if I can reach my destination or not. So that sort of problems are there in an electric vehicle because the size of battery is limited. If you are going on a two-wheeler, you cannot carry a LPG cylinder size of battery with you. So those sort of space limitations are there, weight limitations are there. So a two-wheeler hybrid vehicle, like sir mentioned, I think it's a very good idea. Let us discuss, sir, when you have a chance. We can definitely collaborate, especially if you are having a hybrid vehicle in a two-wheeler. You don't need a full capacity of let's say it can be like we did. If you remember, we discussed one time in your university whether the source of power can be combined parallel or series. Those sort of combinations we need to see. And if you see, I think it's an excellent idea. We can definitely collaborate, sir. After your program is complete, let us talk, sir. Let us see how best we can collaborate with each other. I want to bring out a product which is for the other participants of this particular faculty development program. Let me share my experience with Godavari University, Godavari Global University. I have been given the opportunity to work with GGU students for the last 2 years, wherein we have developed a prototype which purely runs on electric vehicles, which is being currently tested. And as the university professor has suggested that we should work on hybrid two-wheeler also, we are ready, sir. Let us plan, meet, but we need an interdisciplinary team, sir. And not only automobile, we need members from electrical, we need a team from electronics, and we need team from mechanical as well. So if we can jointly do it, I think it is very much possible, sir. That's only recommended, only suggestion from my side, sir.
Good. Thank you very much, sir, for accepting our request. Definitely, we will meet.
Yes, sir, sure.
Sir, this is Suraj from Kumaru College of Technology. I actually saw your website and I dropped a message to contact you because I didn't have some contact information directly to reach you out. So because we want to work with our patents to get realistic, so that's why we are contacting you. And another thing is, if any internships or anything is there, we are likely to upgrade our skills and everything. So can you please let us know? We already dropped a contact us, so you can revert back on that one itself.
Sure, sir. Where is your college, sir?
It's in Coimbatore, sir.
Yeah, sure, sure.
But I'm basically from the Andhra Pradesh only, but I'm working in the Coimbatore college.
Yeah, sure, sir, sure.
Yeah.
If the students are eager and They
Yeah,
are
actually, they are like,
passionate.
yeah,
Passionate. The only thing we see in students is whether they are passionate or not. Second thing we see is whether the students are what you call
basic
having
knowledge.
basic knowledge. Also, no problem, sir. We can teach them, sir.
Okay,
Attitude, only attitude.
I understood. I understood.
Passion and attitude. That's all.
Okay. Yeah, it is good to connect with you, sir. So if we get in touch with both of us, then we can connect to our students also. Then you can choose the people according to your things.
Yeah, sure.
Yeah, yeah.
We are actually doing it for GGU students also. We can do for other people also. No problem.
Yeah. So I just looking forward to receive your mail from your side.
No problem. No. My email address is there in the last sheet. I will put it up now. 1 minute.
Okay.
It is there. If you want to take a screenshot or a photo.
Yeah.
No.
I took. Yeah. Thank you. I will contact you through mail by tomorrow. So then we can have a deep discussion then, and also I will contact you by call. So then we can get in touch.
No problem. My phone number is also there. If you can drop a WhatsApp message also,
Yeah.
I'll try to reply as soon as possible.
Okay. Thank you. Thanks.
Dear participants, there are any further questions? Can interact. So if there are no further questions, then
Okay, I think.
Ramprasad garu, this is Jayalan.
Sir, Dr. Garu, how are you, sir?
Fine, sir, fine. So I've been watching you and very curiously and with a lot of patience. You are addressing all the concerns, and I really thank you for extending your cooperation to provide some sort of internships and collaborative projects as our HOD mechanical and automobile Subramaniam requested you through this platform. And another colleague from my colleague, I don't know him, but from Coimbatore, he is also quite enthusiastic in sending their students to get collaborate with you. So great, sir. Thanks for your time and all, and accepting once again from our end, right? So Srinivas Reddy, are you there?
yes, sir. Yes.
Yes, Srinivas Reddy. So, if no other questions from any of the participants, then we can wind up the session, I think.
Sir, Mr. P.V. Ramprasad garu. So, on behalf of Godavari Global University, I would like to extend our sincere thanks. So, you have been with us for so long, and you have been delivering these kind of very lively sessions, which are very enthusiastic and encouraging the young researchers, and particularly leading us towards the importance of entrepreneurship like yours. So the present scenario, if the state only rolls out the notification about our policy, so it is not only enough. So promoters are also required. So people should know, because as you know, even the highly educated person, they don't prefer to go through the long policy documents. So we don't consider that as much as important as others. But these sessions, I feel they are very important because we teachers are there in this FDP. So we can share the same information with our students to drive them towards the innovation and entrepreneurship. So thank you very much, sir, for enlightening us with government policies which are there now. And you patiently asked each and every question. So we thank you for that, sir.
Thank you.
Sir,
There
one
is,
more question. Yeah, one more. Yeah, from
yeah,
chat. There is one more question in the chat.
chat.
So here, yeah, in chat.
Yeah. Okay. Do you want?
Srinivasan, sir, you
Sir.
can unmute yourself and please respond as quick as possible so that we can wind up the session.
Yes, sir.
Yeah. Yes. Yes.
So, how we can collaborate? For example, if we want to have some collaboration with your company, RenEV, what's the procedure? How can you approach you, sir?
Actually, we are trying to grow, sir. It is not having a big layered structure. If you have any what you call collaboration opportunity you have in mind, be it a student internship or collaboration to develop any sort of product or anything you have in your mind or your students, we are ready, sir. You can drop an email to me, or you can drop a message onto my mobile. Anything is okay, sir. Means it depends. Where are you calling? Where are you attending the program, sir?
I'm from Chennai, sir.
No problem. You can definitely get in touch on my mobile and email number. Let us see, sir, how we can collaborate. You are from an engineering college, sir?
Yes, sir. Yes, sir.
Yeah, sure. No problem, sir.
Thank you, sir. We'll approach you then.
Yeah, sure. Sure.
Okay, sir. Then thank you. Ramprasad Garu, we'll catch up once again. We'll be
Thank you,
waiting
sir.
for you. Whenever you find time, try to visit our university. And our university doors are always open for your presence.
Thank you, sir.
Because we have
Thank you.
been, SRKR products are so patient and always smiling. They give answers with a lot of things. Okay, Srinivasan sir, thank you very much. Thanks for your concern. I mean, thanks for your interest and all. Srinivas Reddy, let us wind up things because it is almost all fast approaching. Up to 9, na, Srinivas?
Yes, sir. Yes, sir. Up to 9, sir.
Okay, we can wind up.
Thank you, sir. Thank
If
you.
no other questions are there. Thank you, Ramprasad Garu.
Thank you, sir.
Thank you,
Thank
Thank you, all
Ramprasad
participants.
Garu. Thank you, Ramprasad Garu, and thank you, Dr. Jayanand Garu, Principal, and thank you,
sir.
Srinivas Reddy Garu. Good night,
Good
dear
night, sir.
participants and my dear students. Thank you very much for your patience listening. Have a good day. Good night.
Thank you, sir. Good night.
Good night, sir. Participants, this is it for today. So tomorrow we will meet for session number 9 and 10. Thank you.